Hello and welcome back. This is one of the final notes in the class. I'm going to go over the final project, and I'm also going to talk about, in today's video, I'm going to talk about peer review. Why is it important? So again, what I want you to have is a package ready to go. You're going to post the package in GitHub, and I gave you a list of examples of students who posted their work in GitHub and what does it entail. But one of the things that is really important for me is that you're going to conduct peer review to your work of your colleagues. And so you're going to review their work and you're going to examine what is the overall impression, how many unique functions your colleague create, does the package has a description file, and does the package has a data set example. So why I'm so obsessed with code review? I prepared some notes on that, and I want to go over it with you together just to make sure that the idea. So the challenge of large code base is to ensure that, first of all, we have actual code, and it is readable, and it has bug free. This is the issue of everyone in the workplace, in any company or any institution that runs code, is that we are trying to avoid code that is corrupt or has bugs in it. And so the idea here is that we have machines that actually can do the debugging, but it always not finding the problems that the code might have. So again, we have different testing mechanism, but it doesn't improve the code, it doesn't help us. So the idea of code review is the idea that, like in writing, in article writings, we have spell checker, we have author editing is on article, but we have other people that read the article, give comments in order for us to review or to improve our article. The same goes to code. There is no difference between that. And so the mechanics of the code review is who, what, and when. When the original developer and reviewer, sometimes in one person, sometimes in offline. What is the idea of give suggestion to improve the structure or maybe the functions that it outlined. Feedback leads to, again, to a second round of code, which always get better and better. Eventually approve the code if there is show that the actual the comments that you receive have an effect. And author always have to have some insurance that this code is good. So why bother? Because forces code authors have to make decisions. And so the idea of running it through other people's eyes help you to make better code, better programs, and better articulate what you are trying to do. So it is count as, again, as committing to the code in order for it to be better. And so the average default detection rates, unit testing is usually 25, function testing is 35, integration testing is usually 45. But those machines cannot implement or examine the design on the inspection of the code itself, and usually it's between 55 to 60%. So I will give you a list of all famous people who wrote about code review. I know from my own experience as a coder and one who used to receive the feedback from my peers, it is usually not pleasant experience. However, it helps. So it helps you to improve, it helps you to understand, again, the idea how to fix it, how to implement. Your job is to make the life of the reviewer easier by putting footnotes in order for them to understand what you've done. So it is the inspection, the walkthrough, and the code writing which makes your code better. So actual people in Google, Amanda Camp says all code that gets submitted needs to be reviewed at least by one other person, and that's Google. And this is part of the work schema that they have. And Alan Feinberg in Help says that we have a system. We have a review board, and everyone who writes the code has to be reviewed, and the same day, and the idea of it is again to apply that. And another one is MTGo, again reinforce the idea of peer review in order for you to apply that. Even Facebook has a peer review functionality that all the people in the company have to go through, and again part of the idea. So I am missing one presentation here, or just give me 2 seconds. Okay, so I did the okay, my mistake. So again, in R, what are we looking at the R? First of all, you as a reviewer has to start with the description. What is the description says? What about the load of the required packages? Are they accessible? Can you find those packages? Then consider what working directory you are working in the scripting sourcing of the script, which means that if the script is not directed correctly, it might have a problem. Use the commands to mark off sections of the code. Put function definition at the top of your file or in separate file if there are many. Name and style is always need to be consistent. Break into small pieces and make sure that it will consist of. The factor out. The factor are common operating rather than repeating them. Keep all the source file of the project in one directory and have access to them. It is part of your job as a reviewer to see if they provide those files. Keep track of the memory used in your program when you review other people's packages. Always start with a clean environment when you are doing that, so you will not run into problem. Keep track of session information in your project folder. Have someone else review it and use version control. So again, the idea of it, I gave you a link to RStudio and how to manage your application or manage part 2 with GitHub and RStudio, just to make sure that everything is synchronized. So in this class, you're going to review your peers project based on the rubric. How many functions did you find? How many notation did you find? Did you find the following folder of data, the R code, description, README, and the source? Any recommendation for this package to become better? You will find those elements in the following description. Overall impression of the work, how many unique functions, does the package has description file, does it has namespace file, and does it has data example? Those are the rubric that you're going to be assigned, and I hope you enjoy it. I hope that you will learn from it to see other people work, because open source R is open. Everything that you've done this in class will be transparent to everyone else, and this is the objective and this is the idea of peer review. So you will hear from me one more time before the final class, asking you to evaluate me, because it is important to me. I hope you enjoy the semester. I hope you'll find the final project challenging and important, because for you who are looking for a job, this will be a good starting point to sell yourself or to show what you know, what you gain. And for those who are going for academic position, R is becoming a standard, so they expect you to know R, and I hope that this class help you. So until next recording or next meeting, I hope you enjoy it. I hope you evaluate me. Enjoy. I will be here to answer any of your questions. Until next time, have fun.